I'm excited to discuss a workflow we've developed for assessing the accuracy of variant calling pipelines. First of many benchmarked workflows at Truhl. In this video, I want to discuss benchmarking in general, give a short walkthrough of submitting a job, and then explore our performance metrics table. There's at least 4 different types of workflow-enabled benchmarking approaches we want to support at Truhl. The first involves the existence of a gold standard best practice truth set. The user can then compare the results using their favorite pipeline against a best practice workflow using the truth set as a rubric. A second type of benchmark involves a situation in which the workflow itself is not in question, but you have a new cohort of data you want to check against an existing results set. The third is a bake-off, where you have a number of different tools you want to try against an existing data set. The fourth involves either periodic quality control or a scenario in which many wet labs want to run the same assays and compare in silico results to some standard. All 4 of these approaches can utilize our benchmarking tools. So our variant benchmarking workflow builds off of the work done by NIST and PrecisionFDA for their Truth Challenge, but it's just the first of many workflows we want to enable with our benchmarking display. This pipeline uses hap.py to generate metrics from comparisons of VCF files to known truth sets over user-specified regions. We've compiled these reports and visualizations generated by the pipeline into notebooks that display directly in the web browser. Users can either directly upload VCF files, or if they're located in a bucket, simply type in the URI. Benchmarks can be performed on any member of the Ashkenazi trio, and we preloaded 8 category winners from the Truth Challenge to serve as a comparison for individual reports. At this point, users can select a test among 4 popular genomic regions, though we will soon release over 123 other genomic stratifications provided by NIST. When the run is complete, you'll see 2 primary outputs visible below, but you can also view all the raw outputs directly in the bucket. The first link is to a multi-QC report that's generated from BCF tool output. The second report contains upset plots that display the overlap in called variance between each of the chosen Truth Challenge competitors, along with the primary input for HL0B. As you can see, there's a lot of overlap on all 7 for both the exome and MHC regions. Also included are precision recall plots for each of these competitors. Unique to this system is an interactive dashboard specifically designed to compare runs across truth sets, tool choices, and parameter distributions. The interface and internal implementation borrow concepts of model and hyperparameter exploration tools from the machine learning community. A high-level dashboard quickly allows users to display subsets of columns among the dozens of manipulated parameters and relevant metrics and between facets of the benchmarking analysis, such as region, type, and filter. This dashboard enables a data-driven approach to pipeline selection, optimization, and validation, and can also be used in production environments to validate that pipelines and assays continue to perform properly. Display, all the inputs of the workflow are available as columns, and individual metrics, which appear in dark gray, are aggregated from individual runs. Finally, facets, which distinguish repeated measurements across different criteria, appear as orange columns. The table itself can be downloaded as a CSV for subsequent analysis. If you're interested in testing your own variant calls or trying our other workflows, you can sign up for a free trial here.